Hi guys, and welcome to setting up scatter plots. This is the first step in what we're going to be doing with taking data and really analyzing it, graphing it on scatter plots, making a best fit line so that we can predict values in the future. This is kind of how we deal with real world data. So here we have some data about some fruits, different fruit, and how much energy is in them. You would think of energy as how many calories are in it, and then how many carbohydrates are in it. For fruit, the carbohydrates are mostly going to be sugar. Okay, so the first thing that we have to do is figure out what's the independent variable and what's the dependent variable. Here you want to think about, is it going to be, if there are lots and lots of calories, is there going to be lots and lots of sugar? Or if there's lots of sugar, does that mean there's lots of calories? And so for us, it's going to be that the sugar is really going to have the effect on how many calories are in it. So if there's a lot of sugar, it's going to be a lot of calories, and that means that our independent variable is going to be the carbohydrates, and the dependent variable is going to be the energy. Once we've done that, we're going to go ahead and we're going to put our axes on the graph. All right, here's our x-axis and our y-axis. Once those are on the graph, now we have to figure out how we're going to deal with these numbers, how we're going to come up with units to put along the axes so that when we get our graph, it's not all scrunched in one place and it's not going off the graph, so that it's just nicely spread out throughout the graph. Okay, so what we're going to do, let's go ahead and look at the carbohydrates first. We'll look at the carbohydrates. The smallest is about 7, and the largest is about 23.5, okay? So it's a reasonably wide range, and if you notice, the data we have has these decimals in it. It's very precise, and so the smaller we can go here, the better. So we want to just kind of make sure that it'll fit, but it's going to be best for us here to go by 2s, and we can just start 2 here. Sometimes we skip some, but 7 is close enough that we're not going to skip any. So we just go 2, 4, 6, 8, 10, 12, all the way up to 26 over here, which is again a little bit higher than we need to go, but that's all right. So our last data point would be kind of somewhere around here. Okay, so now we have the data for the units for the carbohydrates. So now we want to look at the units for the energy. So here we're going from 30 to 92. So that's a range of about 60. That's pretty large. So we know that we're going to need to go by a large number. And in our case, we still have kind of precise values, so we don't want to go by, 20 or anything. That'd be a little too large. 10 makes some amount of sense. If you want to go by 10, you're welcome to go by 10, but we can actually fit this on here if we go by 5s. Imagine that there's a little squiggly thing. It was hard to put in the PowerPoint, so I apologize that it's not there, but we would have a little squiggly right here to show that we've skipped from 0 to 30. And from here on, we go by 5s all the way up to the top line here, which would be 95. All right, so now we're going to write down that the proper unit for the x-axis, that's the carbohydrates, is 2, and the proper unit for the y-axis is 5. Remember what that unit means is just what we're going by, how many is going to be in between each line. Okay, so now we just need to finish up the setup of our graph by labeling and titling it. So we're going to put the labels on the axes. These are the carbohydrates in grams, and the energy in thousands of calories is what that means. That K means kilo, which is 1,000. And then finally, we want to title our graph. If you want to come up with an exciting title, that's fine, but we can always just go to the old standby, just the X versus the Y, so carbohydrates versus energy. And that's how we set up the graph.